Hello, so I'm Mrs. Imms and I am going to talk to you about atomic structure. So in today's lesson, we are going to be covering what an atom is, essentially what it is composed of, and what sort of mass it has and what charges it has. Now, I know that those are a load of keywords and they might be very, very difficult to understand at this moment in time. But as we go through this PowerPoint, we will essentially learn these keywords, learn what they mean, and hopefully by the end of the lesson, you'll have a clear understanding of what I am actually talking about or referring to. Now, as this is covered in your atomic structure and periodic table module, what I will need you to do is have a periodic table to hand at all times, just because any time that we're talking about atoms, we would be referring to particular elements, and that is essentially where we would find our elements, we would find them on a periodic table. So it's always, always useful to have a periodic table to hand. Okay, so as I said to you, we are going to be looking at the structure of the atom. So essentially, I will just reiterate, we are going to be covering what an atom is made up of. So it's got three subatomic particles, and we're going to learn about those today. We are also going to explore essentially the mass of those subatomic particles, and we're also going to be looking at the charges of those subatomic particles too. Okay, so here on my PowerPoint slide, you will see that I have a range of atoms. Now, all I've done is I've just gone into Google, essentially, and I've typed the word atom, and these three images have come up. Now, as you can see, they are very, very different to one another. And there isn't really, if we go into Google, there isn't really a clear understanding of what an atom is. Okay, now luckily in science, because of many, many years of research, we have actually managed to depict what an atom essentially looks like. So I am going to be using, and further on in when it comes to your course and when it comes to this module that you're looking at, we will only be looking at this example, this model, okay? Now, this model essentially shows us what an atom is composed of. And as you can see, I've got loads of different circles. I've got black dots, I've got green dots, I've got yellow dots. They might not make any sense at this moment in time. However, we are going to learn about those today. We're also going to learn about the rings, essentially, or the shells that circle those black dots and those dots that you can see. So we're going to learn about that in a little bit more detail. Okay, so atoms are very, very small, and this is the reason why it took very, very long time for researchers to understand what it is essentially that an atom looks like. Because atoms actually can't be seen. They are that tiny and that small that we can't see them with our naked eye. So it makes it incredibly difficult to actually understand what they're made up of if they are that small. So, just to put it into perspective, an atom, there is no way you'll be able to hold it in the pinch of your hand. Absolutely not. They are minute, they are so, so small, and we can't see them. I've got a red blood cell here, which is essentially very, very small. And an atom is way, way, way smaller than that red blood cell. So, again, they're even smaller than that. This image here is of a virus. Okay, now viruses are really, really tiny, absolutely incredibly small. And again, we're unable to see them with the naked eye. However, again, an atom is actually even smaller than this. So an atom has a radius of about 1 times 10 to the power minus 10 meters. Okay, now if I was to put that into a number, it would look something like this. Okay, so as you can see, I've got the number on my right-hand side. Now, I'm not going to go and read out all of those zeros, but atoms are minuscule. They are so, so minuscule. Now, the reason atoms are so, so important is because everything is made up of atoms. Your chair that you're sitting on, your table that you're working at, your laptop, every single thing is made up of atoms. So we essentially need to understand what they are and what they were composed of. Okay, now it's very, very difficult to determine, the structure of them just because they are so, so small. Now, there has been research obviously conducted in this sense with other scientists essentially who have been able to depict how we came to this resolution. But we're not going to be looking at that today. We are just going to be focusing on what an atom is made up of. Okay, so atoms are made up of three subatomic particles. Now, if you have a look on my PowerPoint, you will see that I have some green circles, I've got some blue circles, and then I have got some yellow circles. Now, some have positive signs in, some have negative signs in, and some have nothing. Okay, so we're going to learn about that a little bit more in detail. So the first one that I'm going to mention is the protons. So the protons are this nice green color and they've got a plus sign inside of them. Okay, so I'm just going to draw your attention to those. The next one is the blue circles. Now these are what we call neutrons. Okay, now notice how the protons and the neutrons are in the same location. They're in the same place. And lastly, we have got our electrons. So our electrons are those tiny little yellow circles with negative signs inside. Okay, now when we're looking at our periodic table, I want you to have a look at it now for me. So looking at our periodic table, what we can see is a range of elements. Now, these are all elements that essentially we have within the world. And some of the elements, for example, gold, silver, copper, we might be familiar with. We might have seen those, we might have used those, we might have jewelry that has them in them. So every single element on the periodic table has a different combination of protons and electrons. And therefore, this is essentially what makes up that atom. This is what makes it look the way it does. That's what makes the element look the way it does and behave the way it does. Okay, so the nucleus is what we say is the center of the atom. So if I just draw your attention, when I spoke to you previously, I said the protons and the neutrons were together. Now the protons, I'll just remind you, are the green circles that you can see with the positive charge inside. And the blue circles, well, those are our neutrons. So the nucleus contains protons. Now these are positively charged and they have a positive charge of +1. Okay, so protons are positively charged. Now neutrons, as you can see, they didn't have any signs inside. So neutrons are what we say are neutral. And that means that they do not have a particular charge. They have what we say, or they are what we say as being neutral. So they are zero. Their charge is zero. So having a think about this, if we've got protons and neutrons, okay, they have a relative mass of 1. Now, mass and charge are completely different. So just remember this because comes up as a very, very key GCSE question. They tend to ask you this a lot. And it's in reference to what are the charges of the subatomic particles, protons, neutrons, and electrons, but then what is the mass of that? The subatomic particles, protons, neutrons, and electrons. So the mass for the protons and neutrons is +1. So again, not to confuse you, but I'm using the words sort of not interchangeably, but at the same time, because I want you to familiarize yourself with the fact that charge and mass are completely different. So the question that I am now asking you is what is the overall charge of the nucleus? So having a think about it. The nucleus contains protons and neutrons. The protons have a +1 charge and the neutrons have a neutral charge of 0. So what would be the overall charge? Well, how would we work that out? So what we would do is we would take the protons +1 and we would plus 0, okay? Because we're adding those charges together, to get an overall charge. So my proton has a +1 charge, my neutron has a 0 or a neutral charge. Therefore, that means overall, my charge for my nucleus is +1 or positive. Okay, so now what we're going to do is we're going to explore the next subatomic particle, and that is our electrons. So electrons, they orbit the nucleus in shells. Now, as you can see, around our nucleus, which is at the center of an atom, we have these sort of rings that circle an atom or circle the nucleus. Now, we refer to these as shells, okay? Now, you may hear of them being referred to as energy levels or fixed distances from the nucleus, okay? So different energy levels or shells. Now, electrons have a negligible mass, okay? They're so tiny, we can essentially say that they don't have a mass. However, for the purpose of this and for the purpose of your exams, we would say that it is 1 over 2,000, okay? So their mass is so small and so minute that they technically don't have one, but we would put this down if we were provided with a table or asked for the mass of an electron. Electrons are negatively charged. Now they have a charge of -1. Okay, so you'll also hear about valence electrons. Now, valence electrons, okay, are the electrons that are in the outer shell. So they are in that last circle, okay, the one on the outer side, the one furthest away from the nucleus. Now, the electrons in the outer shell take that part in the reactions, okay, and we'll learn about that in a lot more detail later on in this topic. Okay, so we now have what the structure of an atom looks like. So we've got our three subatomic particles, which are our protons, neutrons, and electrons. We've got our shells, which the electrons sit on, and we've essentially got our nucleus in the middle, which is composed of protons and neutrons. Now, just having a look at this image that I've presented to you with, I want you to think about what do you think is between the nucleus and the shells that the electrons sit on? What is between those? Because essentially, if this small concentrated mass is in the middle, which is our nucleus, and then we've got these shells on the outer side, what is between the nucleus and those shells? Have a think about it. Okay, so I'm hoping that most of you have thought nothing. Okay, so there is absolutely nothing between them. There is so much distance between them. However, there is just empty space, complete empty space. And this was very clear in an experiment done by a researcher. However, we're not going to refer to that just yet because we will explore that in a lot more detail. But there is just empty space between the shells and the nucleus. Okay, so the radius, now when we're talking about that space, we can look at it in a lot more detail. So the radius of a nucleus is less than 1 over 10,000 of the radius of an atom, okay? So the nucleus is minuscule. It is so small. Now to put this into perspective, what I've done is I've prepared an animation just so you can see how small this nucleus actually is in reference. So it is absolutely tiny. We can hardly see it. Okay, so the mass is concentrated at the center. Now, as you can see, we can hardly see our nucleus. Okay, and then around or surrounding that nucleus, we've just got this empty space, a lot of empty space between the shells and that nucleus, which is ever so small. Okay, so what we've got now is a small little quiz. Okay, so we've got a small little quiz that is going to essentially assess your learning and what you've learned from this slideshow. So the first question that I've got is which two subatomic particles have a charge? Is it the electrons? Is it B, the neutrons? Or is it C, the protons? Okay, so I'm hoping that you will have said, oh, if it's going to work, that it's the electrons and the protons. Okay, so the two subatomic particles are the electrons and the protons. Now, hopefully you remember that the electrons have a negative charge of -1 and the protons have a positive charge of +1. Okay, which two subatomic particles have a mass? Okay, so now in this case, it is the neutrons and the protons. So do you remember we said that the electrons had a negligible mass? Essentially, it was so small, so minute that, we would say it's 1/2000. However, um, it's so small that we can basically say it doesn't really exist. So our neutrons and our protons, now hopefully you remember that our neutrons and our protons both have a mass of +1. That one's sort of already nearly been given to you. I've just shown you that. But which subatomic particles orbit the nucleus in shells? Well, I hope you will have said the electrons. And as you could see, those were those small yellow circles with the negative marks inside of them. And essentially, those are our electrons representing our -1 negative charge. Which two subatomic particles are found in the nucleus? Is it A, electrons, B, neutrons, or C, protons? Okay, and again, we've got our neutrons and our protons. Okay, those were found in our concentrated mass, which is our nucleus, and then the electrons are found on our energy levels or our shells on the outside of the nucleus. Okay, so we've got true or false. So the whole atom has a mass. Is this true or false? Okay, so it is false. Okay, so the whole atom has a mass. Well, no, the whole atom does not have a mass because we are aware that the electrons have a negligible mass. And in that case, the whole atom cannot have a mass. The protons and neutrons do, and we have a +1 charge, not charge, mass for that. However, the whole atom does not have a mass. And then justify your answer. Most of the atom is empty space, or the atom is a solid sphere. Well, we know that the mass or the nucleus is so concentrated and so tiny from our previous slides. So we saw how tiny it was, and therefore all of that surrounding area, or where those shells exist, is where we would find a lot of empty space. Okay, what is the radius of an atom? Now, we covered this right at the beginning, so you're more than welcome to pause the video and go back and have a look at the couple of slides if you have forgotten. Okay, and the answer is B. It is 1 times 10 to the power -10 meters. Okay, so this is for you to do. So what I would like you to do is pause the video here and essentially draw or complete the following table. So you'll be looking at the charge of your electron, neutrons, and protons, your mass, okay, whether it's +1, -1, or 0, or negligible, and then the location, so where we would find them. Would we find them on the shells? Would we find them in the nucleus? So answer the questions below. What is the overall charge of the atom? What is the overall charge of the nucleus once you are finished? Okay, so the electrons have a -1 charge. Hopefully you've got that right. If you haven't, what you can do is you can take a different coloured pen, preferably a purple pen or a green pen, and you can make your alterations. We've got our neutrons, which have a 0 charge. We've got our protons, which is +1. Our mass, which is 0. Mass for neutrons, which is +1. And mass for protons, which is +1. And then our locations, hopefully you would have said that our electrons are found in the shells, and then our neutrons are found in the nucleus, as well as our protons. So what is the overall charge of the atom? I'm hoping that you would have said that it was 0 or neutral. Now, the reason that it is 0 or neutral is because if our nucleus has a +1 overall charge and our electrons have a -1 overall charge, when we get +1 and we add it to -1, we add those two figures together, we will get overall 0. Okay, so we would get 0 or neutral. What is the overall charge of the nucleus? Well, it is positive. Now, as I said to you before, our protons have a +1 charge, our neutrons have a 0. Okay, they have a neutral charge, and therefore +1 add 0 just gives us +1, so it would be a positive charge. Okay, so I've got a 6-mark question to finish off. So it's to describe the structure of the atom with reference to all the subatomic particles, relevant masses and charges. Now I've got some pointers to help you answer this question. So when we are answering this question, it would be nice if you could write it out in full answers. However, when it comes to the examiner, if you were to bullet point the answers and it did consist of the 6 marks or the 6 things that would be found on a mark scheme, you would get the marks. So what are the 3 subatomic particles of an atom? If you can answer that in a full sentence, it will be perfect. What charge does a proton have? How about a neutron? So again, you've just completed those tables. Feel free to use those tables to enable you to answer this question. What charge does an electron have? Where are protons and neutrons located? And then where are electrons located? What is between the shells and the nucleus? Okay, so if you pause this here, these are the 6 points that I'd like you to cover in this question. So it's going to take you roughly about 6 minutes to do. If you pause the video here, the next slide, we will go through the answers. Okay, so the atom is made of protons, neutrons, and electrons. Those are our 3 subatomic particles, and that's what we're referring to. That's what an atom is composed of. Protons have a positive charge, whereas neutrons have a neutral charge. They have a charge of 0. Electrons have a negative charge, and we know that that charge is -1. The protons and neutrons can be found in the nucleus in a concentrated mass, but just remember how tiny that nucleus actually was. The electrons are in shells, which are round the outside of the nucleus. And as we know, the rest of the atom is empty space. Okay, now if you were to depict a diagram, if you were to draw a diagram and annotate around it, whilst making sure that you've mentioned these points, or for example, if you'd drawn a diagram with the electrons, protons, neutrons and put the charges in place, you would sufficiently score a lot of those marks or obtain a lot of those marks. So just remember that, you can, if you are struggling, you can always bullet point and you can always draw diagrams in order to help you with your answer as well. Okay, so I've come to the end of the atomic structure. Please obviously refer back to your notes, have a look over what we have done today, because it will be really, really useful for when we look at, for example, mass and working out the protons and electrons of particular elements next lesson. Take care.